Good afternoon and welcome to ElectroBIM training. My name is David Robison. Today we are going to be looking at new features in the beta release of ElectroBIM 2.2.1. If you're attending the training live, you can ask questions in the chat box. If you're watching a recording of the training, you can contact our support team using the options on our website. So let's go ahead and get started looking at these new features. The first one I'm going to highlight is that this release of our software supports Revit 2025. Normally, we would try and support the new version of Revit on the current, not the beta version, but Revit 2025 was a pretty big upgrade internally. They switched from the .NET Framework 4.8 to .NET 8. That's not going to matter to you because you're just an end user and you're not doing the development, but internally, that was a pretty big just kind of API change on Revit side. So that required us to make some changes to our internal libraries. And so we just wanted to have a chance to put that, to shake out any bugs that do come from that. So that's why that's in the beta rather than in the active release. So if you're jumping onto Revit 2025, you will need to get the beta. It looks like everything's working fine. We're not seeing any issues, but just because of the changes of all the libraries, we put that in the new version of our software rather than the existing version. So if you got Revit 2025, we support that on the beta. Now we can look at the new features, and these are for all versions of Revit. Back to Revit 2020 is what we're currently supporting with new features. The first is the ability to upsize wires for voltage drop automatically. So if I go to my voltage drop schedule, this is the standard schedule that ElectroBIM creates. And you see we've got these exclamation points. That's where we previously were highlighting that values exceeded the voltage drop ranges that you set in your project. But you had to then go back and manually change your wire sizes to account for that. We've added an option to do the upsize automatically. It is an option because I sent out the email letting everyone know about these new features, and an almost immediate reply back was, oh, that's an interesting feature. Is it required? Because I don't want to use that on my project. And there's lots of reasons why you might want to use it. There's lots of reasons why you might not want to. So that's why we have an option for it, because we anticipated that not everyone was going to want that feature. So if you go to project options, that is where the options are going to be. In this voltage drop section, we have three limits that we check against: the limit for feeders, for branch circuits, and for the total. Previously, these were drop downs, 2 or 3%. We switched that. They're just numbers. You can type in anything you want. So if you want to do 2 and 3, if you want to do 1 and 4, however that is. The older versions of the NEC had it as 3% feeder, 3% branch circuit, and 5% total. They've actually changed that. So their recommendations currently is 2% feeder, 3% voltage drop, and 5% total. That's actually a little bit simpler because if you have the 3, 3, and 5, then you have to figure out where you're going to do your cutoff if something's above 5%, but not above 3% on the others. The upsizing works better with our software where you're not trying to have that leeway in there. When we're doing our upsizing, we're going to check against the feeder in the branch circuit. We don't use this total at all. So we're checking against these values. Then we have the option as to whether you're going to upsize your feeders and upsize your branch circuits. On current projects, when you open them up, by default is going to be set to no. So we're not going to go changing all your wire sizes on your current projects. So everything by default, nothing will change. New projects, if you're using our out-of-the-box customization, these will actually be set to yes. So new projects will start with this set to yes. You can obviously change it, or you can set your customization files that you import and you export to have this set how you like in your projects. We'll change it from no to yes for feeders and from branch circuits. Then we also have this upsize multiplier, again, both for feeders and for branch circuits. This is how big it'll make a wire before it stops upsizing it. For branch circuits, it just sets a maximum. It's like it's not going to make it any bigger than that. So if the wire ends up 10 times bigger than what needs to be to account for voltage drop, it's just going to stop and it's just going to let the voltage drop exceed the 3%. On the feeders, what this means is it'll take a feeder, it'll double its size, and after that, it'll actually go to other feeders in the line. So it gives you some ability to adjust how this upsizing is going to work. Because if you have one feeder that needs to get really, really big, maybe there's another feeder that should be checked instead. So after doubling the size, we'll go and make changes on other feeders in that run. And when we're looking at the feeders to upsize, we look at the whole run back to the utility. And so we find the feeder with the most voltage drop on it, and we do the upsizing there. So we'll leave this as 2. Then the other voltage drop settings, those are all the same. And now we can run our calculate, and we're going to see a number of these values change. So we'll run the calculate. This here, the EP22 is going to be the main one that we can look at. It's at 3.26%, and we actually changed it from 3 to 2%. So there's a lot of values here that are above 2%. So these are all going to change. All right, and now it is done with that calculation, and you can see that we have no more exclamation points. All of our wires have been upsized. So this EP2 is now down at 1.93%. So it's got bigger wires here. I think this is a bigger wire. Everything down here has been adjusted as well. All our branch circuits, everything is below 2%. Actually 3%, because that's what we said. We also added a new schedule, the voltage drop review schedule. This will tell you which feeders and branch circuits we have upsized. So you run this, it creates this schedule. It's a standard Revit schedule, but it's formatted nicely so you can see what values we've changed. We created new shared parameters on your circuits for your original wire size and your original voltage drop, and we use that for the schedule. We also tag whether the branch circuits are a feeder or a branch circuit, and then we use that for the grouping. So we have all of the feeders up at the top, all of the branch circuits down at the bottom. It will tell you the panel it's on, and then the circuit, and then the description of that circuit. Then we give you the original wire size, the original voltage drop, and then the new actual wire size or the new actual voltage drop. So here you can back check the changes that ElectroBIM made to your wire sizing. So on this feeder to PP2B, it went from that 250 kc mil to 2 runs of 250 kc mil. So it essentially doubled it, and then I had to go look for other feeders in the run to make the adjustments to get the voltage drop down. Same way for all of your branch circuits, we're listing what their sizes and voltage drop were and what their new size and new voltage drop is now. And that is how that new feature works. So again, you can turn that on and off in the options. Any questions on that before I move on? There's a lot going on calculation-wise. I have a feeling there might be some questions, so I want to just pause on this feature and let you ask any questions. We can come back to them if you don't have any questions yet. But if you do have any, go ahead and throw those in the chat. So the question is, how do we account for, or how do we know what size wires to choose when we're doing our upsize? That is going to be handled in a couple different places. First, in wire ampacities, this is where most of your sizing criterias are happening for your project. So this is where you specify your configurations of wire. Out of the box, we have copper and aluminum. I've seen customers who've expanded this. So you can have other options. And then for all of these, we have these checkboxes on this right-hand side as to whether this is a standard size for branch circuits, equipment circuits, and feeders. So for branch circuits, we're going to be using the branch circuit column. For feeders, we use the feeder column. And these are set for each of these groups up here. So this one is the copper group. So this is using all copper wire. I have a similar group that's the aluminum that's going to size to aluminum wires. So one of these is active. And so that's going to be the default in your project. All of your wires are sized based upon the active by default. So when you're doing the upsize, it's going to be looking at these wire sizes, it's going to be looking at these copper feeders and sizing based upon that. If I changed it, for example, to this one, it would do copper for the small wires and then aluminum for the larger wires. So I could change my active sizing option here, and that would cover it for the whole project. So that's how you adjust your default for the whole project. You can then, on specific runs, change what that one run is going to use. So say we want just this first run from the utility service to be aluminum. We could change that here from this conductor. By default, it's using our copper sizing. We could change it to use that aluminum grouping instead. So we change it to aluminum. It's now going to size it automatically based upon those other selections. So it's going to use those choices and give you an aluminum wire instead. So that's how it's choosing which selections to use when using the upsizing. It basically starts where it is and then just goes up for each one that's set as a standard size. Does this do anything with upsizing grounds? Yes, it does. So previously, if you changed a wire size, we would upsize the ground automatically, because that's just what the NEC calls for. If you change it, if you increase a wire size, you need to upsize the ground. The voltage drop, it's going to work the exact same way because we're changing that wire size off of the default. We'll know that it's being changed off the default, and so the ground will upsize correspondingly. So grounds are upsized properly. Are these upsizes only performed when calculating the whole project? Yes. So we do our calculations. We do limited calculations when you make changes on something. We don't calculate the whole project. So if you change a single feeder size, when you make a change to this wire size, it's going to give you the new voltage drop. So we calculate the voltage drop on that feeder immediately. We don't calculate the whole project because you don't want to redo the calculation every time you do a whole project. If you set it to default, it will kind of look and kind of do some upsizing. On the circuits, it's going to do a little bit better of a job because branch circuits are pretty straightforward. There's really only this one thing. You don't have to look at the whole run to do the upsize properly. So for example, if we come in here and we change this feeder length and we set this to 500 feet, that's still below 3%. Change it to 1,000 feet. Okay, now it upsized it from number 12 to number 10 immediately and gave you that new voltage drop. However, really for your feeders, you do need to run the calculate to make sure that everything's done because that calculation is looking at that whole run. If we pull up the single line diagram, when we're sizing this feeder here, we really, anything in this run, we have to look at all of these feeders and figure out where the worst case voltage drop is and do that sizing. So it's more complex than looking at just the feeder. So we have to do the whole thing. So we only do that when you run the calculate. So in general, the calculations happen when you do that calculate. We try our best to make some changes when you do little changes, but you got to run the calculate to get everything updated. Does this new feeder get some sort of special mark in the feeder schedule? And is it based on the original ampacity? So we don't notate these on the feeder schedule as specifically upsized. However, since they do have different different ground sizes because of the upsize, that will sometimes come out on the feeder IDs. So if it's upsized and you get a different ground, you'll get a different feeder ID. Otherwise, we're not going to necessarily call it out. It's just going to be a different size. So you'll see here, this PP2B, it's a 200 amp panel. It's a 500 amp feeder. We're not calling it out specifically as a feeder that has been changed for voltage drop. But this is what it would end up looking like. So you have this 250 amp panel, 500 amp feeder pointing over to this 500 in the schedule. Can you turn off voltage drop upsizing per circuit? You can. So you got the options to turn it on or off at the global level for branch circuits. However, you might want to do it for specific branch circuits. If that's the case, really the way to do that is you would have to go to the circuit and really fix the size. So you come in here to the conductor, and when they are upsized, it actually does notate that. So it's showing it here, hey, this one has been upsized to a number 10. So you would have to come in here and manually downsize it back to a number 12 if you wanted to. You'll have to think about whether you want to have this turned on for branch circuits. It might be a little bit too aggressive upsizing your branch circuits because the branch circuit calculations, it might not understand that it shouldn't be doing some of the calculations when it is. So you just have to think through whether that belongs on for your projects or not, and which is going to be the easier case to turn it off for cases where it's upsizing too much, or manually upsizing when it's just doing the manual upsize and not having it doing it automatically. Does the automatic upsize start with feeders from top to bottom before adjusting branch circuits? So we look at feeders and branch circuits independently. So we'll do the feeders and we'll make sure that the feeders all the way through are less than the feeders. We look at the branch circuits and that's just the branch circuits. So there's no interaction between those two. So we keep the branch circuits below the branch circuit level. That's just a one and done. That's really easy. Then the feeders, the way it works is we don't look top to bottom. We look along the entire run. So this is actually a good example where we've got this voltage drop down here that's over 2%. It's actually 3 point something. And so we look at, so it's the voltage drop to this panel. So we look at this feeder, we look at this feeder, and we look at this feeder. And we find whichever one of those has the highest voltage drop, that's the feeder that we're going to resize. And we resize it until we reach that maximum. And then we look at the others. So in this case, we took that 250, resized it to 500, and then we looked at the other two and it found that this one had the higher voltage drop, resized this one. that eventually got us down to where we needed to be. And the assumption is if you have one run that has a really high voltage drop, that's probably going to impact others. So, when we upsize this wire, it's helping the voltage drop on this panel. It's also going to adjust the voltage drop on these other panels as well. So if you do something kind of higher up where it's a really high voltage drop, that's going to help with lots of panels. So that's how the sizing is, the choices are made for the wires, which ones we're choosing to upsize. Is there a parameter that flags that the upsizing has been applied? There is. We have this parameter here, voltage drop upsized. It's yes or no, and that will tell us whether we've upsized the wire on that circuit. And then we use that for our filtering purposes. You could use that for your own purposes as well. So that'll just tell you if we've upsized it for voltage drop. We do have a couple other features included in the software. So I've been playing in Revit 2025 because I just wanted to show that our software works in Revit 2025. I'm going to jump over to Revit 2022, where I have another program called Evolve Electrical installed. This is used by contractors for laying out their conduits and doing prefabrication, things like that. Stuff that our design build contractor customers are interested in, stuff that consulting engineers don't worry about, because if you laid out where the conduits are going to be, the contractors are going to ignore that and do whatever they were going to do instead. So, but for the contractors, it's really important to lay out the conduits. So they have Evolve for that. We added an export last year to take the wire sizes, it's really actually the conduit sizes from our software, and send them over to Evolve so they can use those for laying out their conduits. So we have this export command, and you export it. It takes all the files, all the wire sizes. It makes an Excel file. Then in Evolve, you can import these into their conduit run schedule. And it'll list all of the feeders in the project. So that feature is not new. This has been existing for a year. What we can now do is in Evolve, you lay out your conduits, and then it'll actually start filling in these model lengths and these installed lengths. You can now pull these values back in to ElectroBIM from Evolve for actually setting your feeder lengths in our software. So say we go here, this is the run to MDP2. I'll set this at 100 feet. And I'm now going to export this from Evolve, save it here. And then we can go back to ElectroBIM and we can import that value from Evolve. And it imported one record. So if you go take a look at our panel edit, and if we look at MDP2, you can see that the length is now fixed at 100 feet. So we pull the value in, we set it as a fixed length in ElectroBIM. So it's just using the standard UI, just pulling the number from Evolve. So if it's set to something non-zero, we pull it in. If it's zero, we assume it's not set yet, so we ignore it. We keep using our whatever value you had there before, probably some estimate. But this way we can pull in those specific values. So if you want to do voltage drop and fault based upon how the conduits are actually going to be run, because you're a design build contractor and you know that, you can do that using the two softwares together. If you aren't using Evolve, could you import your own Excel file? You could. And what I would actually recommend if you want to do that is that you can run the export even if Evolve isn't on your computer installed. So you run the export, and then you can open up that Excel file. It's going to have a lot of stuff in here. So you can do whatever you want with this. The names are pretty good in terms of what they are. It's a pretty well formatted Excel file. And then in terms of importing values back in, we're going to use the modeled length, the installed length, or the order length. So, and I think we look at ordered first. And if that's zero, installed. If that's zero, we look at modeled. And if they're all zero, we ignore it. But if one of those is set, we'll use that value. So you can set your values here if you know your lengths and you want to import them back in. So that way you can use that. There are other programs similar to Evolve Electrical that exist. So if you have one of those and you can pull your values from there, you can use this format to import them into our software. We have breaker databases in our software. So we can do selective coordination and arc flash. We've got a pretty good list of breakers, but they're really hard to find if you don't know where they are in our system, because there's a lot of them and the naming is not great. So I'm going to show how you can find these. We've got a new feature. to search for them in our software. I'm going to show you how that works. So I have a couple examples here. I've taken off the names to anonymize them, but these are requests that we've gotten from customers. Hey, I'm looking for this breaker. In this example I've got shown up here, they're looking for a couple Siemens breakers. There's a 200 amp QS, 100 amp QP. So if we put a main breaker on this, and we'll just force this to 200 amps, you run select breaker curve, and this is where you would choose that breaker. You go to Siemens, and there's a lot of options here. We filter it down a little bit, and if you hunt for it, you can probably find it. Okay, that QS, it's probably going to be in here. But it's not obvious where this QP is. And so you had to kind of track it down, and it was tedious, and people would have trouble finding them. We now have this search button. You click on search, and it's going to list all of the breakers that we have, and the ones that actually match that you could use are listed in green. So I could type in QS, and then it'll filter in, oh, hey, there's the QS breaker, and you can select it, and then it'll select that breaker for you. If we wanted QP, we can type in QP, and there's quite a few options that match that, but there's the Siemens QP, which is buried here. In this case, it's not showing up because it's actually not an option that matches, so it's not ever going to show up. So if you had something set wrong and it didn't match in our database, it's not going to find it. So here you can see it. If you try and select it, it's going to complain. It's the breaker size is out of range. But that way you know where it exists, what the ranges are that we have loaded in our software. So this is going to help you find your breakers. Just as another example, customer who was looking for, I think these are a couple Cutler hammer things, and you just got a model number. So if we type in CH215, what comes up? Okay, that actually does show up. And it's a Cutler hammer breaker, but they've actually been bought out by Eaton. So now it's an Eaton breaker. So it's actually hidden under there. And you have to know that it's under this load center. So if we went and looked at the Eatons, the Eatons have quite a few. So finding an Eaton breaker is like a needle in a haystack. So you use the search and it can find it. So we can look for the other one, the CH230, and that finds it pretty easily. And then they also have this GE breaker, the THQL. So again, if you go to the GE, there's a lot of options. If we type in THQL, it'll find your options there for you. In this case, there's actually a lot that look like they're the same. They're actually different ampacities. So if we had an ampacity that matched, it'll highlight again which ones are going to match. This customer, they were looking for some Bussmann FRS fuses. So you can type FRS, and then it finds it. Here, there were some ABB breakers, and all we have is this catalog number. So you kind of start typing in numbers and see what shows up. So XT1H. And so nothing shows up. So then you kind of got to figure out, well, what is actually going to be, what can we find? So if we get rid of that X, so you get rid of the H, and then we can find it. So that is a new option for tracking down breakers in our database to make it a lot easier for you to find those when you're trying to do your breaker curves. We have a new option for our transformer feeder IDs. Previously, we used this J, because you've got we have two types of grounds in the software. You've got the 250-102, which is service, 250-122, which is equipment. So equipment is most of your grounds, and then service is when you're connecting to transformers or whatever, a separately derived service. We needed some way to differentiate which ground was being used because you have different ground sizes for the same size wire. We didn't want to use S because S is too similar to 5. So I didn't feel comfortable using that in our default IDs. And then you kind of go along the list of other first initials. And J is their supply side service jumpers. So we chose J because it was at least kind of in there in that section. I've never loved that. And another customer, when I was talking to them, suggested T for transformer, because 90% of the time when you're using a service ground, it's because you're connected to the utility transformer or an internal transformer in the project. So we changed that so that our default now is to use T rather than J. That is, of course, an option, because if you've been using our software and you've got a bunch of stuff using J's, you don't want to switch in the middle. So we have the option for J for jumper, T for transformer, and I threw in S for service ground if you want to use that. Again, I don't love it, but you can choose the S if that's what you would like to use for your projects. So existing projects will default to J, new projects will default to T. If we change that to T and we go to our feeder IDs, And I'll just get rid of everything. And we redo our calculations, it'll change this J to a T when it remakes that feeder ID. And it still found that J, I believe, because I have one more option I need to turn off. It's importing from the master. The other feature we added was an update to the instance edit window. The main thing that you're going to be interested in is that it now supports edit multiple. So instance edit can now modify multiple devices at once rather than just one at a time. In a previous release last year, we did this for the panel edit command. We're going through and making this change for all of the commands in our software, just taking a little bit of time. So we did panel edit previously, now we've done instance edit. So if I go take a look at some receptacles, if I select these two receptacles and run our instance edit command, it will select both of them, and then you can make changes to both of those receptacles at the same time. We do still have the legacy instance edit. So for whatever reason, the new one has any sort of problems, you can go back to the legacy. You can still get to that. That'll eventually be removed once we're out of beta. But we left that in there just in case. But we've got the instance edit. It's a slightly different look and feel as well. We changed our internal framework to support, just to make this more future-proof. But in terms of functionality, the main improvement you're going to see is the fact that you can edit multiple instances at the same time. And just looking forward, the next releases, we're going to have circuit edit with edit multiple. So you'll be able to select multiple circuits and make changes. And then the family edit, where you're making changes to your families, that's going to have a multiple edit multiple in there as well. So you can change multiple types at once. And that will finish up all of our edit commands, and they'll all have edit multiple at that point after the next release. Thank you for watching today's ElectroBIM training. Contact us with questions or comments by emailing support@designmaster.biz.